You are standing in the middle of everything you need. Shade overhead, water nearby, animals moving through the grass in patterns your group has memorized over generations. The fruit comes back every season. You know where the predators sleep. You know the names of every person around you. There is no famine here, no drought closing in, no catastrophe on the horizon. And yet someone in your group is already looking past the tree line, already restless, already gone, in every way that matters. What if the urge to leave wasn't a response to danger? What if at times was the danger hardwired into certain bodies before birth, ancient and unstoppable, and completely invisible to the people who carried it? The answer isn't one thing. It's never just one thing. There's a gene involved, a selection filter so brutal it makes the journey look gentle by comparison, a network of information stretching 900 kilometers across a continent that no one had ever fully crossed, and a twist at the end that reframes every civilization you've ever heard of. Let's go. The first myth is the obvious one. Humans left because they had to. Resource collapse, drought, predator pressure. The environment failed them, and they walked. Except the evidence doesn't support that. Richard Potts, at the Smithsonian Human Origins Program, published research in Times Science, Times in 2013, showing that the major human migration events out of Africa correlated not with environmental collapse, but with variability, oscillation between wet and dry, climate that kept shifting without settling, and the populations that stayed in stable, abundant zones showed slower cognitive development. Migration-linked populations showed a 30% faster rate of tool innovation across 500,000 years of fossil record. The departure from East Africa around 70,000 years ago happened during a period when Lake Malawi levels indicate times wetter, more productive times, savanna conditions, not drought. The Gravettian culture expanded across Europe 30,000 years ago by moving times toward time's glacial margins, not away from. The Polynesians launched into the open Pacific from a homeland that was already resource-rich. Nobody pushed. Natural selection, it turns out, rewarded the ones who left early before crisis arrived because the ones who waited for crisis were already too weakened to survive the journey. Comfort wasn't a reward. It was a warning sign evolution taught us to distrust. Now here's where it gets biological. The desire to explore is not a personality trait. It is not a cultural value passed down through stories. There is a specific variant of the DRD4 gene called DRD47R that is directly associated with novelty seeking, risk tolerance, and an inability to feel satisfied by routine. Chuansheng Chen at UC Irvine published a landmark analysis in Times Evolution and Human Behavior Times in 1999, examining DRD4 allele frequencies across 39 populations worldwide. DRD47R appeared in up to 32% of nomadic and high migration history populations. In sedentary populations, that number dropped to 8%. The mechanism is dopamine. The allele reduces dopamine receptor efficiency, meaning carriers need times more time stimulation to feel the same reward signal. Staying still, for these people, felt neurologically like starvation. The Arial nomads of Kenya proved it clearly. DRD47R carriers in nomadic communities were significantly better nourished than non-carriers. But move those same carriers into settled communities, and the gene flips. Suddenly they're times worse, times nourished than everyone else. The gene didn't just correlate with wandering, it only worked inside of movement. Indigenous South American populations show DRD47R frequencies, nearly double those of the East Asian populations they descended from the journey across the Bering Land Bridge, filtered for the allele. The restless ones made it. Some people weren't born to wander, they were born unable to stop. But here's the thing, none of this explains. If the instinct to leave was this powerful, why did anyone stay? And the answer to that question is darker than the migration itself. Because the people who left weren't fleeing misery. Wolfgang Hack at the Max Planck Institute published isotopic analysis in Times Nature, Times in 2015. Strontium and oxygen signatures pulled from 69 ancient European skeletons. The Yamnaya migrants who swept into Neolithic Europe 5,000 years ago were times taller, had denser bones, and showed fewer childhood stress markers than the European farmers they displaced. Those farmers had stored food, established settlements, agricultural infrastructure. and they were still losing the health comparison. The Clovis people entering North America 13,000 years ago showed excellent skeletal health at the point of entry. The first Lapita settlers of Vanuatu, per David Reich's ancient DNA work from Harvard in 2016, carried zero Papuan ancestry. They bypassed already inhabited islands entirely. They weren't desperate. They were choosing. Long-distance migration required metabolic reserves and social cohesion that only a group times above times a baseline of well-being could sustain. Misery stayed home. The people who built new worlds weren't running from ruin. They were running from enough. And the act of moving changed them. Andrea Migliano at the University of Zurich published research in Times Science Advances, Times in 2020, studying Agta hunter-gatherer networks in the Philippines. High mobility groups had significantly denser social structures, more non-kin connections, faster information transfer. Each additional camp moved per year correlated with a 17% increase in novel tool variants within a decade. The Upper Paleolithic creative explosion in Europe, 45,000 years ago, didn't develop slowly. It arrived with time's Homo sapiens, time's migrants from Africa, like a package already assembled. Microblade technology across Asia between 25,000 and 18,000 years ago tracks migration routes almost perfectly. Movement didn't follow intelligence. Every mile they walked rewired what it meant to be human. Now, the part nobody tells you. For every migration success, there were dozens of catastrophic failures. Marcus Feldman at Stanford modeled this in Time's PNAS, Times in 2012. Each time a subgroup broke off to migrate, they carried only a fraction of the parent group's genetic diversity. By the time humans reached South America, the founding population may have carried as little as 83% of the genetic variation present in the African source population. The entire indigenous population of the Americas descends from a founding group of fewer than 250 individuals per Pontus Skoglund's work at the Francis Crick Institute in 2021. All non-African humans alive today descend from a group that may have numbered as few as 1,000 to 10,000 at the moment of the out-of-Africa migration. Near extinction, over and over. The groups we know about are the 1% who survived. We are not the descendants of the brave. We are the descendants of the lucky. There's one last thing I saved for the end. What did they actually follow? Not just rivers and animal herds. Francesco De Rico at the University of Bordeaux published analysis in Times Nature Human Behavior Times in 2021 showing that identical ochre pigments and shell beads appeared at Middle Stone Age sites up to 900 kilometers apart before any evidence of permanent settlement connecting those locations. They were exchanging symbolic objects across distances that required coordinated long-distance relationships. And the migration routes that came later tracked those exchange corridors almost exactly. Obsidian from the Greek island of Melos appeared on the mainland by 13,000 years ago, requiring open water crossings. Spondylus shells from Ecuador arrived at Andean highland sites 2,000 kilometers inland before the Inca road system existed. They weren't walking into the unknown. They were walking towards someone who already knew. And when that walking stopped, when geography trapped a population with nowhere to go, the results were brutal. The Dorset people of Arctic Canada maintained cultural stasis for 4,000 years. When the Thule migrated east from Alaska around 1000 CE, the Dorset vanished within 300 years, leaving virtually no genetic trace in modern populations. Ancient DNA analysis by Manasa Raghavan at the University of Copenhagen in 2014 confirmed they did not interbreed with incoming populations. A people who had stopped moving had stopped adapting. The Rapa Nui of Easter Island completed one of the most extraordinary open ocean migrations in history, then found themselves geographically caged, with no further islands to reach. The same energy turned inward. Monument building escalated into competition, then ecological collapse, then warfare. Population may have crashed from 15,000 to 3,000 by European contact. The migration instinct with nowhere to go became self-destructive. The rule isn't that humans migrate. The rule is that humans must expand their horizon, or they will find another way to detonate. Here's the zoom out that changes everything. Every major feature of civilization, agriculture, cities, writing, trade, law, emerged not in the places humans had lived the longest, but in the places they had times just arrived: the Fertile Crescent, the Indus Valley, the Yellow River Basin, Mesoamerica, all transformed within a few thousand years of new human migration. The wandering didn't end when civilization began. Civilization times was times the wandering finding a new form. The DRD4-7R allele still exists in roughly 20% of the global population today. Aviation, the internet, the first crewed missions toward Mars. These aren't departures from ancient behavior. They are the same ancient behavior, wearing new clothes. The question was never why they left. The question is why we keep assuming we've stopped.